is the Avro Arrow, Canada's entry into the supersonic era. Within the short span of 4 years, the Arrow was brought from initial design to the start of the development flight program. So vast was this project that during the next 20 minutes, we can do no more than give a series of impressions of the planning and hard work that was required. Early in the design stage, it was apparent that newer fabrication techniques would be needed. Because earlier methods of manufacturing portions of the aircraft skin from sheet metal would not meet design demands, an electronically controlled skin mill was installed to machine skins and structural components from solid metal billets. This 15,000-ton press was also installed by Avro to form heavy-gauge sheet metal parts with the accuracy that the Arrow required. Again and again, in the planning of the Arrow, the development of new manufacturing techniques was made by Avro to meet the exacting requirements of modern aircraft design. This meant the procurement and installation of new equipment with which these new techniques could be effected. In design and manufacturing, new and unexplored areas were being opened up. But this was far from being a purely academic investigation. The whole project was proceeding to a tightly integrated schedule, and it was a complex operation demanding a very precise analysis of manpower, machine, and facility capacities. From the master schedule, detailed programs for manufacture and assembly were prepared, and a smooth, pre-planned release of manpower from other programs to the expanding Arrow production line was effected. The success of this careful planning may be judged by the fact that the first Arrow took 20% less man-hours than projects of similar size and complexity produced elsewhere in North America. There is, of course, much more to designing and building than we have seen so far. It wasn't quite that easy. To see a little more of the work involved, let's go back to the beginning of the story of the Arrow. Avro's initial proposal for the Arrow was completed for submission to the Canadian government in 1953. Design specifications were based on requirements for Royal Canadian Air Force fighters of the future. Following government authorization of a design study, various carefully handcrafted scale models representative of the aircraft design were prepared for the wind tunnel development program. Within a short period of authorization, wind tunnel tests were being run. Models were tested at low and high speeds, and spin recovery tests were carried out. As a practical check of flutter and vibration calculations, a scale model was made and tested because existing theory did not adequately cover problems introduced by the low aspect ratio and complex structure of the Arrow. Records of all tests were analyzed and fed back to the design team. Of course, there is nothing as good as a full-scale model to check installation clearances and general accessibility. A wooden mock-up was built for this purpose and was also used for early RCAF evaluation. The dummy engine used with the mock-up to check installation and removal techniques is a full-scale model of the Pratt & Whitney J75 engine used in the first Arrow aircraft. The lighter, more powerful Orenda Iroquois engine is scheduled for installation in later Arrow aircraft. It has already been flight tested in a B-47 on loan from the United States Air Force and specially modified for this purpose. Using the mock-up, RCAF specialists were able to assess servicing requirements and make suggestions for design changes. Close cooperation between the Air Force and Avro has been a notable feature of all stages of the Arrow program. A similar metal mock-up was built by the manufacturing division to establish and to check manufacturing methods, assembly, and work sequences. This early wooden mock-up of the cockpit showed that the windscreen, as originally designed, would be subject to distracting reflections. Using the mock-up, it was possible to correct this condition and check the result before a single aircraft had been built. A program of structural and systems test was begun at an early stage in the project. A large number of test rigs had to be specially designed and constructed for this work. Some of the rigs were of a relatively simple nature. Others, such as the fuel system test rig, were much more complex. It was used for investigations into fuel system functioning under simulated flight and ground conditions. The Arrow is fitted with Martin Baker seats for ejection of the aircrew under emergency conditions. Records of tests conducted to analyze the operation of the escape system show its effectiveness. The Flying Control System test rig is a full-scale replica of the aircraft system from the cockpit controls to the control surfaces. It is possible to reproduce flight loading on the rig and to conduct simulated flight tests. The automatic flight control system and analog computers provide simulated flight response. A complete full-scale air conditioning and pressurization system was developed in this rig. The rig can be fed with heated high-pressure air to reproduce the full range of operating conditions met in flight. This rig simulates the complete aircraft electrical system. It is used to check out electrical components or wiring assemblies before installation in the aircraft. It is possible to show only a brief representative selection of the many structural and systems tests which were performed as part of the Arrow project. The testing of systems in rigs, simulating flight and ground conditions, the testing of materials to ensure that they would meet design requirements. All this was carried out with one primary aim in mind. The first aircraft was not to be a handmade prototype. A comprehensive test program to prove all aspects of design was therefore necessary before starting tooling for production.